Hello everyone, welcome to new class. Today's class is about modulation. So let us go through the class. So what is modulation? Modulation is a method by which some parameters like amplitude, then frequency or phase of the radio wave are varied in accordance with the information to be transmitted. So, the method by which the parameters like amplitude, frequency or phase of the radio wave, which is called the carrier wave, are varied in accordance with the information to be transmitted is called modulation. And the reverse process, that is the extraction of this information from the radio wave at the receiver, is known as demodulation. And there are different types of modulation techniques. So the modulation is classified into two, that is continuous wave modulation and pulse modulation. Then continuous wave modulation is again classified into two, amplitude modulation and angle modulation. Then angle modulation is again classified into two, frequency modulation and phase modulation. Then pulse modulation is again classified into digital pulse modulation and analog pulse modulation. In amplitude modulation, the amplitude of the wave is varied, then keeping the frequency and phase constant. Whereas in frequency modulation, frequency is varied, then here the amplitude and phase is kept constant. Then in phase modulation, the phase of the carrier signal is varied in accordance with the instantaneous value of the modulating signal, keeping the frequency and amplitude constant. So let us study about the amplitude modulation in detail. And in pulse modulation, the signal is transmitted in the form of pulses. Some examples of analog pulse modulation are pulse amplitude modulation, pulse width modulation and pulse position modulation. Then digital pulse modulation means it is pulse code modulation. Let us study about amplitude modulation. So, in amplitude modulation, the amplitude of the carrier wave. So, this is the amplitude. Amplitude of the carrier wave is varied in accordance with the instantaneous values of the modulating signal, keeping its frequency and phase constant. So, this is the carrier wave and this is the modulating signal and this is the modulated wave. So, carrier wave means it is the wave of constant frequency and amplitude, and modulating signal means it contains the information to be transmitted, and the modulating signal may be audio signal, video signal or any digital signal, and this is the modulated wave. So, this is in the case of amplitude modulation. So, here the amplitude of the carrier wave is varied in accordance with the instantaneous value of the modulating signal, keeping its frequency and phase constant. Let the instantaneous voltage of the modulating signal B, Vm is equal to Vm sine omega mt, where Vm is the amplitude of the modulating signal and omega m is the angular velocity of the modulating signal. Then let Vc is equal to Vc sine omega ct be the instantaneous voltage of the carrier signal, where Vc is the amplitude of the carrier signal and omega c is the angular velocity of the carrier signal. So, when the amplitude Bc of the carrier signal varies in proportion to the instantaneous values of Vm of the modulating signal, then amplitude modulation is obtained. Let A be the amplitude of the amplitude modulated wave. Then we can write A is equal to Vc plus Vm, and that is equal to Vc plus Vm sine omega mt, because here amplitude of the carrier wave is varied. So we can write Vc plus Vm sine omega mt, and which we can write Vc into 1 plus, that is Vc we take outside, so we can write 1 plus Vm by Vc sine omega mt. Let Ma be Vm by Vc, where Ma is the modulation index. So we can write A is equal to Vc into 1 plus Ma sine omega mt. So this is the amplitude of the amplitude modulated wave. Now we can write VAM, that is the instantaneous voltage of the resulting amplitude wave. We can write VAM is equal to A into sine omega ct, because here omega ct is same as that of the carrier wave. So we can write amplitude A, that is amplitude is changing here. So we can write A into sine omega ct, and that is equal to, put the value of A here. So Vc into 1 plus Ma sine omega mt into sine omega ct, and that is equal to Vc into, that is opening the bracket, we can write Vc into sine omega ct plus Vc Ma sine omega mt into sine omega ct. And we know the identity sin A sin B is equal to cos A minus B minus cos A plus B divided by 2, or 2 sin A sin B is equal to cos A minus B minus cos A plus B. So from that we can write VAM is equal to Vc sine omega ct plus Ma Vc divided by 2 cos omega c minus omega mt minus Ma Vc divided by 2 cos omega c plus omega m into t. So the amplitude modulated wave is the sum of three high frequency components. They are, the first one is Vc sine omega ct, which is the original carrier wave, and the second term Ma Vc divided by 2 into cos omega c minus omega m into t represents the lower side band of amplitude Ma Vc divided by 2 and frequency Fc minus Fm. Then the third term is Ma Vc divided by 2 into cos omega c plus omega m into t, which represents the upper side band of amplitude Ma Vc divided by 2 and frequency Fc plus Fm. And here the amplitude A of the modulated wave has a maximum value of Vc plus Vm and minimum value of Vc minus Vm. Next is sidebands and frequency spectrum of AM wave. The frequency spectrum for a carrier frequency signal modulated by a single audio frequency signal is shown in the figure. When an RF carrier is modulated by AF signal wave by mixing the two frequencies, two new frequencies equal to sum and difference of the combining frequencies are formed, and the two new frequencies, that is Fc minus Fm and Fc plus Fm, are called the sideband frequencies. The frequency Fc minus Fm is called lower sideband frequency, and Fc plus Fm is called upper sideband frequency. And the two new frequencies which appear on either side of the carrier frequency are called sidebands, and the sidebands carry the complete information. Next is bandwidth. The total frequency range occupied by the modulated wave is known as its bandwidth. So, the bandwidth required for AM wave is Fc plus Fm minus Fc minus Fm, and that is equal to 2 Fm. Hence, the bandwidth required for the transmission of AM wave is twice the modulating signal frequency. Fm is the modulating signal frequency. So, the bandwidth required for the AM signal wave is twice the modulating signal frequency. And another term is MA, that is the modulation index MA, and it is the ratio of the amplitude of modulating signal to the amplitude of the carrier signal, and it is also called depth of modulation. So, modulation index or depth of modulation. And in amplitude modulation, the amplitude of the carrier wave is varied in accordance with the variation in the amplitude of the modulating signal. So, the extent of variation in the amplitude of the modulated wave can be expressed as the degree of modulation or depth of modulation, which is called the modulation index. And MA, that is the modulation index, lies between 0 and 1. And if it is expressed as percentage, then it is called depth of modulation. Next is frequency modulation, FM. So, in frequency modulation, the frequency of the carrier wave. So, frequency means 1 by time period. So, here the frequency of the carrier wave is varied in accordance with the instantaneous values of the modulating signal. And here the amplitude and the phase of the carrier signal remains constant. So, here frequency is varied in accordance with the instantaneous value of the modulating signal. And here the amount by which the carrier frequency is varied from its unmodulated value is called frequency deviation, denoted by the letter delta. So that is about the basics of modulation. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.